All right. Okay. So I have shared the screen again. I repeat, today, this is the very first class. We are going to discuss the first chapter, that is quadratics. Okay. The first thing which we have discussed is quadratic function. It is a polynomial of second degree. You guys know what a polynomial is? It is any mathematical expression with x in it, like x squared plus 1, like x cubed plus 2, and so on. So it is a polynomial with second degree. This means that it is going to be an expression of this type where the highest degree is going to be 2, right? So this is a quadratic function. Okay. Now we have a few examples. 5x square minus 8x plus 13. Gayatri, what is a in this example 1?
2.
A is this. A is the coefficient.
5.
Excellent, excellent. Okay, very good, right? All right. And then B is minus 8 and C is 13. Okay, very good. Right. And if I talk about this third example, here we only have A and A is 6. So one thing is very clear. Although this is the general form of a quadratic function, but it is not necessary to have this and this term, okay? We are going to have the x square term every time because obviously we need to have x square. We need to have the highest degree as 2, okay? This is why they are saying every other coefficient B and C could be 0, but A cannot be 0, right? So is this thing clear? Can I rub this all? Yes, guys, are you clear with this? Okay, all right. So I'll clear this. Right, and now we will talk about factorizing a quadratic function, okay? So the first topic is factorization of a quadratic function. Okay. So you guys must be familiar with factorization. Let's say, I'll give you a quick example. Let's say I have x cubed plus 2x. If I want to factorize it, I can take x common and I'm left with x squared plus 2, right? So this is how we factorize expressions. But here we are talking about quadratic function, okay? And not this simple function. Here, obviously, x can be taken common because we had x in both these terms. But if I talk about, let's talk about two examples. If I talk about x square plus 5x plus 6, I want to factorize this expression. Apparently, I cannot see anything common in all these expressions, right? For factorization, I need common thing or common variable in all these, but I can't see any common number or variable in these three terms. So let's see how to factorize it. And if I talk about another example, so here I can use 3x square plus 11x plus 6. Okay. So I have these two examples. Let's factorize them together. Okay, I'll tell you how to factorize such an expression. Now, for factorizing quadratic function, look at this C. This was the general form. So this is C, right? Look at this C. We need two numbers such that when we multiply them, we get 6x square, and when we add them, we get 5x. Okay, this is how we factorize a quadratic function of this type, okay, with three terms of this form. Okay, so I'll think about the factors of 6x square because I know I need two numbers such that when I multiply them, I get 6x square, and when I add them, I get 5x. Okay, so one possibility is that I multiply 2x with 3x, And I know that when I will add 2x and 3x, I will get 5x, right? So we have to stop here and we got our numbers. So this would be x square. 5x can be written as 2x plus 3x plus 6. Why 2x and 3x? Because this is what we got. Now I can take common. Now I can take x common, x plus 2 plus, now I can take 3 common here, 3, and then again I have x plus 2. Now the tip is that this factor would be same as this one. If this is not same, this means that you have made a mistake. Okay, so be very clear with this. These two factors should be same. And finally, we have x plus 3 into x plus 2. Okay, so we started off with this quadratic function and finally we are able to factorize it. Okay, so are you guys clear with this? Yes, no? Are you guys there? Okay, so okay, and what about you, Haris? Is this thing clear? Okay, perfect. Right, so I'll be asking you guys continuously because only then I'll know if you're able to understand the question or not. Right, now we have another quadratic expression, 3x squared plus 11x plus 6. Again, we have to factorize it. Okay, and how do we factorize it? We need to think of two numbers such that when we multiply them, we get 18x squared. Why 18x squared? Because I have to multiply this and this. 3x squared into 6 is 18x squared. Okay, so I need two numbers such that when I multiply them, I get 18x squared, and when I add them, I get 11x, right? So if I think of the factors of 18x squared, I will get 18x squared if I multiply 6x with 3x. Yes, okay, but that is not going to give me 11x, it is going to give me 9x. Then if I think further, I can get
9.
very good.
9 to 18.
Yes, 9 and 2x, okay? So we know that 9 and 2 will give us 11 and 18x square as well. So 3x square would come as it is. 11x can be written as 9x plus 2x, and then we have 6, right? So, okay, now we are in the form. Now we can take things common. I can take 3x common in from both these expressions, okay? So I can take 3x common. I will be left with x plus 3, and from here I can only take 2 common. So I have x plus 3. Now again, as I told you before as well, this and this, these two factors should be same. This is how we are going to know if we are going in the right direction or not. And finally, we have 3x plus 2 into x plus 3, right? So is this thing clear? Okay, perfect. Right. Okay, let's talk. We are done with the factorization. Now we have to see how to solve a quadratic equation. Okay, so solving a quadratic equation. Okay, now let's talk about solving it. Okay, so let's talk about this as our example. 3x square plus 11x plus 6 equals 0. Now, in the previous part, we have discussed how to factorize it, but since we have to solve when we say solve, it means we need to find the values of x, right? So obviously it would be an equation. We can only solve an equation. So you guys should be very clear with the meaning of solve. When we say solve, it means to find the values of x, right? So in the previous part, we have discussed how to factorize it, and the factors which we got were x plus 3 and 3x plus 2 equals 0, right? So in the previous part, we discussed how to factorize it. We got these two factors. If this was equal to 0, so I've written it again. This is equal to 0, right? Now we want to solve this quadratic equation. We want values of x such that when I plug the values of x, like when I plug in these values, I get 0, right? So the first step is to factorize it. We factorized it already. So we got our factors equal to 0. Now we know in maths, whenever we have two numbers that are equal to 0, this could be because either A is 0 or maybe B is 0 or maybe both are 0, right? Because 0 into B is also 0, A into 0 is also 0, and 0 into 0 is also 0, right? So when two factors are being multiplied and we are getting 0, it means that either this is 0 or this is 0. So we get x equals minus 3 from this factor, because obviously I'll take x to this side because I'm interested in finding the values of x. And for that, I need to separate x. So I'll take 3 to that side. And if I talk about this factor, I have 3x equals minus 2 and x equals minus 2 by 3, right? So this is how I will solve any quadratic equation. So is this thing clear? Okay, and yes, Gayatri, what about you? Okay. You guys can like talk as well. I don't mind that. I mean, if you want to, you can unmute your mic and ask me questions and tell there as well. Okay. Then we have, okay, now this is one way of solving a quadratic equation. Obviously, we were able to make factors here. So we directly made factors and we said either this would be 0 or this would be 0. So either x could be this or this. But it could be that we are not able to factorize a quadratic equation. If we are not able to factorize a quadratic equation, that does not mean that we are not able to solve it. We still can solve it using a formula, and that formula is quadratic formula. Okay, so I'll write down that formula. Okay, so one way was to factorize and then equate to 0, and the other way is using quadratic formula. Okay, so the general form of any quadratic equation is ax square plus bx plus c equal to 0, and the quadratic formula is x equals minus b plus minus under root b square minus 4ac over 2a. Now this is a general formula which you can use for solving any quadratic equation. Okay, it could be that in your quadratic equation your b is 0. You have, let's say, x square plus 1 equals 0. Even for such type of equations, you can use this formula. In this case, a would be 6 because 6 is the coefficient of x square, b would be 0, and c would be 1, right? Okay, this is first thing. And then the second thing is, here you can see plus and minus sign. This plus and minus sign means that you will get two x's. Whenever you are solving a quadratic equation, the maximum number of roots or solutions could be 2 because the power is 2, right? So is this thing clear? So we can also write it this way: minus p plus under root b square minus 4ac over 2a, and x2 could be minus p minus under root b square minus 4ac over 2a, because we will come across two roots. Okay, all right. So this is done. Okay. And now if we talk about the nature of roots, okay, let's talk about it here directly. Now you guys know that this quadratic formula right here can be used for any quadratic equation, right? Now you need to understand a few things. As I said, that this 1 and 2 is basically telling you that whenever you will solve a quadratic equation, the maximum number of roots which you can get is 2. Okay, by maximum I mean it could be that you get one root or no roots, right? So how is that possible? Let's talk about that part over here. Okay, now there's a very important thing which you guys need to understand, is this part right here. This is the discriminant. Okay, this is the discriminant, and if this discriminant, that is b square minus 4ac, is greater than 0, it means that in this under root thing we will have a positive function. If this is a positive function, it means that like there's no problem, we will get we will get x1 from here and x2 from here. Okay, right? So this is what we usually expect. But then if b square minus 4ac is equal to 0, if this thing is equal to 0, then obviously we have minus b over 2a in x1 and minus b over 2 in x2. This means that we will get same roots, right? So this thing means that we will get two real roots. This means we will get repeated roots, right? x1 and x2 are same. Okay, and the third case is when b square minus 4ac is less than 0. Now, when b square minus 4ac is less than 0, this means that in the under root we are getting a negative number. And whenever we get a negative number in under root, this obviously means that if you do that on your calculator, you'll get an error. This means no real roots. Okay, so I'll sum up everything once again. We are discussing how to solve a quadratic equation. We know first method is by factorizing it and then equating it to 0. But factorizing if the quadratic equation is not possible, right? So it could be that you are not able to factorize it, but yet you can solve it. How? Using the quadratic formula. And this is the quadratic formula. If I break it up, this is for x1, this is for x2. We have plus in x1 and minus in x2, right? But we usually write it this way with a plus minus sign. Okay. Now, this thing is important. If b square minus 4ac is greater than 0, you will get two real roots, right? If b square minus 4ac is 0, if this thing is 0, then there's no difference in x1 and x2. So this means you will get repeated roots. And if b square minus 4ac, this part is negative, this would mean that you have no real roots. You will come across an error and you have to stop there and then. So minimum number of roots which you can get from a quadratic equation are 0 and maximum number is 2, right? So is this thing clear? Should we talk about examples now? Yes, Gayatri, are you there?
Yes, miss.
So is this thing clear?
Yes.
Okay. So let's talk about examples, okay? The very first example is, okay, first let me just state the question. So in the following questions, you have to determine the nature of roots of following quadratic equations and find the real roots if possible. Okay. So I'll do the first example and then I want you guys to do the second one. Right. So the first example is 2x square minus x minus 10 is 0. Okay. Now again, this is a quadratic equation and the general form of any quadratic equation is ax square plus bx plus c equals 0. Now the first thing is I have to determine the nature of roots, right? How am I going to do that? By talking about the discriminant. What is the discriminant? Discriminant is b square minus 4ac, right? Let's see what is a in our example. A is 2. What is b? What is b?
1.
1.
Minus 1.
Very good. And what about c?
Minus 10.
Yes, it is minus 10. Okay. Now let's just use ABC in this formula just so we can find the nature of our roots by finding the discriminant first. So b square would be minus 1 square minus 4 into 2 into minus 10. This is going to give us 1. Minus into minus is plus. 4 into 2 is 8. 8 into 10 is 80. This is 80. So this basically is 81 that is greater than 0, right? Our discriminant is positive. So it implies we will have two real roots. Okay? We will have two real roots. You can also write we will have two real and distinct roots. Why am I using this word distinct? Because it could be, obviously, our roots are going to be real, otherwise, we will have no solution. But it could be that our roots are same, right? We have repeated roots. So, since this is positive, it is not zero, it means that we will have distinct roots, right? So, let's find the roots now. The formula is x12 is minus b plus minus under root b square minus 4ac divided by 2a. Either you can find it by factorizing it or directly using the quadratic formula. So in this case, since we have already calculated this, the discriminant, we can see that it is 81. 81 is a perfect square. So I can easily just plug in the values. Minus b would be 1 plus minus under root b square minus 4ac is, yes, what is this, Haris?
G.
What is b square minus 4ac in this example?
इसमें b square minus 4ac है
81,
एक
right?
second.
It's
Yeah.
mentioned. Okay, it's segment. Okay. So it is 81. divided by 2. Okay, so this would be 1 plus minus 9 by 2. So I'm going to get x1
Excuse
equal,
me, miss.
yes,
ये 2 जो है a की वैल्यू भी है तो 4 नहीं होगा, 2 2 is 4.
yes, very good, very good. It is, yes, it is 4. It should be 4. Okay, it is 4, right? So it is 4. So we are going to get 10 by 4 and x2 is going to be minus 8 by 4. So this is 5 by 2 and this is minus 2, right? Very good, Gayatri. Very good, Haris. Is this thing clear?
मिस ये x2 को रिपीट करिएगा.
Okay. Acha. For x1, we have to add x1 is 1 plus 9 by 4 and for x2 we have 1 minus 9 by 4. 1 minus 9 is minus 8 by 4, right?
Okay.
Is it clear? Yes, no, yes. Is it clear or not? Okay. All right. Now let's talk about another example. The second example is 4x square plus 20x plus 25 equals 0, right? Okay. So let's do it together, okay? Here again, the first step is to determine the nature of roots. Whenever it comes to nature of roots, we have to talk about the discriminant, okay? Discriminant is b square minus 4ac. But for finding discriminant, it is important to find out a, b, and c. So a is the coefficient of x square, that is 4. B is the coefficient of x, that is 20. And c is the coefficient, is basically the constant. So c is 25, right? By constant, I mean the term without any x thing. So b square would be 20 square minus 4. A is 4 and C is 25. So this is going to give us 400 minus 400, that is 0. Very good, Haris. Okay, it is 0. Right. So since it is 0, what does it imply? This implies we will get,
Less than.
no, this is 0. Okay, this is 0. This means that b square minus 4ac is 0. So we will get repeated roots. Repeated roots or two equal real roots. Right, Gayatri? Since b square minus 4ac is this, that is 400 minus 400. Since it is 0, we know that we will get repeated roots. Why? You will know that shortly. So we have to use the quadratic formula, that is minus b plus minus under root b square minus 4ac divided by 2a. So minus b would be minus 20 plus minus b square minus 4ac is 0. So I can write down 0 directly, divided by 2 into 4, that would be 8, right? So since this is 0, since this is 0, it means that I am getting x1 and x2 equal. That would be minus 20 by 8. So that is minus 5 by 2, right? I'm getting minus 5 by 2. So x1 and x2 are repeated roots. Yes, very good. Okay. So is this thing clear? Okay, and what about you, Gayatri?
I got it.
All right, okay. All right, so let me just clear this. Last example is example number 3. X square plus x plus 1 equals 0. Okay, so I want you guys to find out the nature and find the roots if possible. Okay, I'll give you 3 minutes and you guys can try it. Okay, very good. Haris, excellent. And Gayatri, you can take your time and let me know. Okay, you still have 1 minute.
मिस नेगेटिव साइन आ रही है तो हमारा वो -1 रेडिकल -3/2 आ रहा है.
Okay, so you are getting b square minus 4ac as -3, right?
जी.
Okay, and what are your roots? Okay, so the discriminant is b square minus 4ac. That basically is -3, right? Now, if I tell you, you need to recall b square minus 4ac is basically the discriminant. How do we write it? Minus b plus minus under root b square minus 4ac over 2a. If this thing is negative, and just do it on your calculator, you will see an error. Okay, you will get an error. If you are getting error, this means that you have no real roots. Okay, since this thing you cannot have under root -3. Okay, right, Gayatri? You cannot have under root
Yes.
-3. So this implies that no
-3.
no real roots, because
The under root is
yes,
-3.
because the discriminant, okay, discriminant is negative. Okay. Whenever b square minus 4ac, that is your discriminant, whenever it is negative, you cannot have solution. Okay. So this, in this case, you will have no real roots. I told you in the very beginning, whenever we have b square minus 4ac greater than 0, you will have two real roots. Whenever b square minus 4ac equals 0, you will have no real roots. And whenever you have b square minus 4ac less than 0, sorry, in this case, you will have repeated roots. And in this case, you will have no real roots. So is this thing clear? Okay, and what about you, Gayatri? Okay, so let's talk about the last topic for today, to express a quadratic polynomial in the form a x plus b whole square plus c. Okay, now here this is a form. Obviously, this is also a quadratic equation, but here whatever quadratic equation would be given or whatever quadratic expression would be given, you need to express it this way. Right. So I'll give you an example and then you will understand. First example is x square plus 6x plus 7, right? Now you have to express it this way. Okay, let's do it. Now, in this case, we need to talk about this number right here. Okay. Are you guys familiar with this? A plus b square equals a square plus 2ab plus b square. This is the general form of a plus b square. Do you guys know this? Okay. And what about you, Gayatri? Okay. Very well done. Right. So whenever we have this, we know that we have 2ab here, right? Forget about this 7. 6x square plus 6x. Write the 7 here and we will add and subtract. In maths, you can add, subtract the same number. Mathematically, it is correct because you can add 0 to any number. So when you are adding and subtracting the same number, you are basically adding 0, right? Because it would become 0 at the end. So if you have 6x, if we have x square plus 6x plus 7, I know that if I write it down as 2ab, this would become 2 into x into 3. This means that my b is 3. So I can do 3 square. You will know why I'm doing this. And I can subtract the same number. Okay. And now if you look at this number right here, this basically is a square plus 2ab plus b square. It is a square plus 2ab plus b square. So I can write it as x plus 3 whole square minus 3 square is 9 plus 7. So this is x plus 3 whole square minus 2. Okay, so I'll explain this again. Here in this section, we are trying to write down any quadratic expression in this form. So what is this form? We have a number here. In this case, our number is 1. We have x plus a number whole square, x plus a number that is 3, in this case whole square, plus c. So it basically is plus minus 2, right? I can write it as plus minus 2. Okay, so I got this. How? By completing square. This is called the completing square method. I had x square plus 6x plus 7. I simply have to ignore the 7 initially and think of this x square and 6x and a third number which would be b square, such that when I have my b square, my square is completed and I can write it this way. So in maths, you can always add and subtract the same number. And why are we doing that? Because we need to complete the square. We have x square plus 6x. We need this number right here just so we can write it in this form, right? So since we had 6x, I got 3 because I have to square 6 by 2. Why? Because I have 2ab here. So if I have 6x, this means that 2x into 3 would give me 6x. So this would be my b and this is my a, right? So finally I have the this form, a into x plus b whole square plus c. So is this clear? Is this clear?